I just want to say thank you so much. It's really interesting winning a third time in a row as most handsome developer. It's been an honor to join this contest. I think I'm going to have to not be here next year because it's just unfair to everybody. What? It's oh, this is the really cool Devnexus talk. All right, let's nerd out real quick. All right, hello, fellow nerds, and instead, let's go ahead and talk about some AI and JavaScript. So, who out there is ready to have some fun? Especially, I want my nerdiest nerds to enjoy this. We are going to be talking about, most specifically, JavaScript machine learning and the concept of magic to science. And the goal here of this entire conversation is for us to learn in the adventures of what's capable and what's possible for people of all walks of starting in machine learning. So I will be your lecturer, your wizard, your just friend for the day, as we're going to be taking a look at things. I'm the mad scientist, Gant Laborde. I'm a Google developer expert in web and machine learning. I have a whole bunch of other accolades as well. Here's a picture of me being identified as a human being by some JavaScript AI, so it is proven. And we're going to have all kinds of fun. And I promise if you are new to all this stuff, this is a great place. If you're familiar with all this stuff, I bet you I'm going to show you something you might not have seen before. So, when I talk about the concept of magic being inside of programming, generally that's pretty looked down upon. But the goal here is that I'm going to be taking that magic and explaining it so that ultimately we end up in science. And this uses that classic Arthur C. Clarke quote, Clarke's third law, which is that any sufficiently advanced technology is indistinguishable from magic. So anybody who's like, "Oh, I don't know anything about I promise by the end of this, you will know a lot more about some of the concepts, some of the ideas, and what's going on in today's world. Most specifically, we'll be doing this fun stuff in JavaScript. So, one question that I often get is why is AI everywhere now? Why is it finishing my sentences? Why is it dealing with, um, you know, adding cool filters on faces and other fun things like that? What happened? And the truth is, if I wanted to have a picture of, identifying kangaroos, I used to have to find, hey, what's up, mate? Take some photos of a kangaroo and email them to me. I want thousands of photos of kangaroos so that I can teach a machine how to identify which photo has a kangaroo in it and not. But now we've been answering captchas for so long, uploading to Facebook. If you just go to Google image search and type in kangaroo, you have hundreds upon hundreds of images that you can show to another person or to AI and then have it learn these new and amazing capabilities. And that's what the magic of it is that now we have the data and our computers have gotten faster and we're able to use our GPUs. And then on top of that, we have these new advanced algorithms because as we start to like break down more and more walls on what is possible with machine learning and AI with all this data and all this processing power, we get new research papers, cool things that are happening every single day. And I know you've been seeing a lot of that. So, unfortunately, that means there's this giant library of information and capabilities and all these cool things that you can do. So, how do you bring this into a talk? For instance, we need to talk about all the different aspects. You got to pay attention to the ethics, speed and accessibility, diversity, working on edge devices, making sure that what we do is both fun, ethical, interesting, and pertinent to what's key. And I think what's great about this is JavaScript really hits all of these kinds of points for us. It's portable. It's ready to be offline. You can go ahead, it runs on the client. It's fun. For instance, Most of our websites, it's easy to create a really fun and simple website and then share that with people instantly. That's how it's flexible. It can go everywhere. It runs on all kinds of devices and machines. And it has access to the GPUs on your computer via WebGL or WebAssembly. All these different kinds of improvements allow us to actually have real power of the machine in JavaScript. And of course, one of the things I think is most important is that if it's running on the client, if it's running on your machine, you can feel confident that it's not sending off your face to Russia to go ahead and log who you are, anything like that. It's private. You can actually watch your network traffic. JavaScript's always been part of, that just view source kind of world, and you know what's going on. So I think that with all these, we can actually accomplish this fun stuff in JavaScript, but it's still such a wide, wide world of we can have all these new capabilities that are key that make it friendly and approachable, but you have to choose. You have to choose because AI can work with sound, and I have tons of cool demos where it works with sound. It can work with text. I have some really bad demos where it works with text. Happy to share those. And then, of course, I think, which is probably the most palpable version, is AI working with imagery, working with visuals. And that's something that's available that we can bring the magic to that as well. But that again doesn't simplify. We need to, inside the visual world, there's all kinds of variety and all kinds of different things that you can actually detect. So I decided we need to have some fun, right? How do we actually demo something interesting in TensorFlow.js? I want you to know there's this classic demo. Those of you who are new will think that I'm speaking a different language or a Harry Potter spell. That's totally okay. Those of you who've done this a lot know about the MNIST data set, which identifies handwritten digits into the frame. So if I draw an 8, it sees an 8. If I draw a 7, it sees a 7. Um, People have been doing this since, the paper was published in 2006. I find this to be exciting a decade ago, a little boring now. So my goal for today is not only to show you this fun new world, but to bring with it a interesting new angle. And so as we're kind of going into this, I think, yeah, let's do some pop culture. So that's the magic side. You can see that I've been bringing in a lot of Harry Potter. So let's bring in some pop culture and let's do some Harry Potter because even if you haven't read the books or watched the movies, I think you can kind of follow along with what we're going to be doing. And so now we're looking for what kind of data can we use to bring to Harry Potter? And if you are familiar, and if you're a fan, what? Go House Ravenclaw? What? Yeah. One of the things you can do here is there's different animals associated with each house. So Gryffindor has a lion, Hufflepuff has a badger, Slytherin has a serpent, and Ravenclaw, we have a raven. And so each of these cool different kinds of icons are available. And I think that that's neat because so we've got the four houses and we've got a different animal associated with each. Wouldn't it be cool if instead of drawing numbers, I drew an animal and then it sorted me into the house that I should be sorted into? So, with this in mind, I said, let's go ahead and try this. Let's see if we can get this done for Devnexus. It'll be a fun project and we can get it set. So, the first question is, where do we get the data? How do you get a bunch of drawings and data? And the trick is, thank you so much, Google, which has the quick draw data set, which has human made doodles, thousands upon thousands of them in 345 different categories. So we could take a subset, a modified set of the drawings from Google's Quick Draw dataset, and then see if we can make our each house's identifier for our AI sorting hat. So that's the idea. And then digging into it, will it work? Is this something that's doable? So the data for Google is available under Creative Commons 4. And then what we do is we grabbed all the different data and I came up with 10 different categories. For Gryffindor, they would have all the drawings of lions and tigers. For snakes, they would have all the categories of snakes. And then I threw in snails because, take a look, snails look a little snaky sometime. Ravenclaw had bird, an owl, and a parrot. And for Hufflepuff, we didn't have a badger. Classic Hufflepuff. I'm sorry, Hufflepuff. I know all you Hufflepuffs are very let down. So you you are constructed of raccoons and squirrels. That's all they had. And they had 10,000 images of each. So this looks very exciting for what we can do here. And so we need the data first. That's the first lesson that we've got. It's like, what is the data that we can get in order to create this cool idea? And thank goodness we had Google Quick Draw. But let's take a look at the data. And so there's this thing to check viability of a classification, which is what this would be. What classification would a drawing fall under? And we can actually identify that using a TSNE, we can try to graph things out. And normally you would like groupings where these don't over interact whatsoever. So you can see snail is up there at the top, and then you can see lion is kind of off in its own and it's doing okay. Owls and parrots being so close to each other, not a problem because they're both going to Ravenclaw. So it's not really going to be difficult. But what you do see is that the squirrel, the raccoon, and the snake are all grouped in very tightly together. So this is going to cause some issues for us because if I'm drawing a snake and I get sent to Hufflepuff, that would be very difficult. So we're seeing some problems with the data right off the bat. So this is the second part that we have in the magic of AI. In the magic of AI, we get the data. The second part is the viability and the cleaning of the data. And if you're new to the world of AI, this section of organization and cleaning and setup is super important. So if you're like, hey, I want to get into this, um, I'm going to make something that helps you get your data and organize it and deduplicates it and does all these cool things. That's an amazing and honestly high paying position. So this is cool stuff where we're getting to for this. So you can see I've got a problem with the data off the bat. And what happens is I need to make the data better. Well, the problem is I checked the data and the best I could get right off the bat was 80% accuracy. Now, that's not bad. As a matter of fact, I think for a sorting hat to be fun, it's going to have to be a little imperfect anyway, right? But when you start digging into the data, you can see that it's got some really disgusting things in it. As a matter of fact, if you look right here, lion with a smiley face under it with somebody's drawing of a lion. Um, no go. No one's going to be writing the word lion. That's not what I want inside my data set, and it's causing all kinds of confusion. Nothing in there actually looks like a lion. So we need to clean the data out. And if you take a look at it, these 28 by 28 size images are fine, except for like that top left one. That's supposed to be a bird, right? Is that a snake or is that a bird? That's difficult. And then the other problem we have is all these written words. So we have people writing the word lion, writing the word snail, things like that they put. And Google hasn't cleaned the data at all. This is just how the data has been retrieved. And in my estimation, at least 1,000 of the 10,000 images of each class are complete trash. So if we're only getting 80% accuracy, we can try a couple of different methods to clean the data and then get it set so that way we can kind of bring this in. And I did all of this in JavaScript and it was a lot of fun. So, first thing I did is that I needed to clean the data. I decided I'd write a web page that would sort of like show me a large amount of data at a time and then allow me to click into it and then delete it. And so I was thinking I could open source this, I could do a bunch of different things. It was a manual process of quickly going through thousands of images and identifying which of them were bad. Um, this sucked. Do not do this. I'm not going to open source that code. I'm not going to share it. It was not a good method. If I had maybe teams upon teams of people, it would be possible. But remember, I've got 10 classes and I've got 10,000 images each. It's 100,000 images. And you think you can get through it. And then the next thing you know, 20 minutes, 30 minutes have gone by. It feels like it was 3 hours. It's the worst kind of work. So maybe there could be some kind of some system that we can come up with where we could kind of send images out, have people work on it for 10 minutes and then send it back. Sort of like, honestly, it's Mechanical Turk, right? And so if you're doing it with Mechanical Turk, I could see this working. For this data set, it was way too much energy for me. The second thing I tried was enlarging the images. Maybe 28 by 28 just meant that it was um, too simplified, too whatever, And so I was like, oh, let's just go ahead and make 128 by 128 images. And then we can see the details and we can get much higher accuracy. That did not work either. So I feel like I want to share this part of my talk for all of you who've ever tried something and then had it blow up in your face and fail. Totally okay. This is what happens. You can continue to fail. It's just you just need one success, right? And for me, it was the last one. I finally had it learn how to identify where the bad information was. And so I taught a model to identify really terrible drawings and then sort of remove those out. So that's what I did. I actually used AI to help me clean the data set for another AI, identifying text, finding things that just were not going to be sortable anyway. The trick is I have complete control over what this data set is. So removing things wasn't hurting me, especially when I've got, I'm going to end up with 9,000 images per category. So the thing that worked for me was the circular method of cleaning. I actually talked to some other data scientists that said like this works for them. That's a pretty cool thing. I'm open to opinions. Did I miss something here? Is there a strategy for cleaning out those ugly images that you could have came up with? I'm interested in hearing specifically what that would be. But that's the one that worked. And then I published the data set. So step number one, 8,000 to 9,000 images of each class, because 1,000 or so plus have been destroyed of 10 possible classes. And I call this the ridiculous data set. And there you are. So you can actually, if you think you can use this information to train something with your JavaScript, awesome. We are going to build something with it in this where we're going to have fun with it and we're going to supply this better than MNIST. But now, if you want to do it yourself, if you're teaching anything like this, or if you're kind of just playing around, these small 28 by 28 images work pretty well. And then with this, we can get at least 90% accuracy, which is great for a sorting hat, right? So we're going to dig in here. So the ridiculous data set that's available on Kaggle, and I can kind of release that as well. And we can start using this data to now make this cool model that's going to bring all that together into a neural network. So, if you're familiar with how to build a convolutional network, then you'll go ahead and you'll know how this works. But for me, I'm going to just kind of explain it to people like it's their first time hearing how to build an AI convolutional network. And this AI network is going to be coded in JavaScript. So, the trick is you have an image in that's a beautifully drawn lion. Good job, Gant, and that's a 28 by 28 one-dimensional image, which because it's only got black and white pixels, it's grayscale. And so what that happens is we grab the convolutions of the image by mapping over it and identifying features like edges, colors, gradients, sizes, all the different fun things that you can do. And then that gets pulled into a max pool layer. And then just in the classic way, you find new features of that and then you pull it. And you find new features of that and then you pull it. So we have all these convolutions that go up front that are layers that are finding features that make an image an image. I like to say it's finding out ways you would describe it. Um, Furry, metallic, shiny, spiky. And so it's just getting all these words that you would normally use to describe it. If you've never done convolutions before, it's basically finding adjectives of the image. And then with all those adjectives of the image, and it comes up with 64 of them, you then connect that to a deeply connected neural network. And so once you've got the deeply connected neural network, it can then identify if it's furry and it's got a tail and it's got feet and it's got like a mane. We're going to go with lion. And if it didn't have a mane, we're going to go with badger or something like that. So you could see that the features of the description of the image help the neural network sort of like train on what's going on. So let's go into a second. What does a convolution look like? So classic convolutions are a computer vision kind of thing where we can tell it to identify specific regions of an image and then pool those so that they come out a lot more. So if you have a photo with a background and all those other cool things like this jack o' lantern has, if you run an edge detection convolution on it, you could see that the pumpkin really pops out for a moment and it identifies all the aspects. It doesn't care about what's in the background except for that one light at the top right. And then if you watch this one moment there, it just sort of like clarifies for a second. That is the max pool. So max pooling is of course taking the most activated portion of each image and cutting it up and making a much smaller image out of that. And so you might be like, uh, I don't really think that works. How can you cut up an image into little pieces and see more of it? Well, for that, I have a video which is really cool. I'm going to share this with you. If you watch this, here's a person cutting up a picture of a dog. And then what they do is they separate it out so that you're only getting half the image there. And then they tape it back up together. And then they cut it along the other axis as well. But you see, it looks like I've got pictures of two dogs here, right? That's two dog images. And then you go ahead and separate these out. And then what happens there is that now you've got four dogs. You can identify that if you're a human being, that looks like four dogs, right? And so that's essentially what I think the same thing in max pooling is, but rather than it being randomized, what you're actually seeing here is more of it would take the best of those photos, the best pixels of those, and sort of kind of brings it on so that the computer can look at fewer features there. So yeah, that's kind of the concept of convolutions and max pooling for you. So how do we write this in code? In JavaScript, it's super, super simple. We just write each layer that we need to. So if we take a look at this, um, models are constantly written in layers, and this in JavaScript, we have three convolution followed by max pooling layers. And you do that with this dot add method, and you give it a layer. So here's one convolution and max pool, followed by another, followed by another. And so that's the code in JavaScript to go ahead and say, give me this image, find the features. Here's the first one. I say, I want 16 features. And then I want you to pull them up. I want 32 features from there, and then there. And then lastly, we're going to end up with 64 features. And I want you to pull that out of here. So then it gives you these 64 features for you to identify what's in an image and then put it together. So the code for something like that, once it's getting fully connected, is it's flattened together and then connected to this neural network. So the neural network's just layers as well. I'm not writing anything significantly advanced here. It's just 100. Here's another layer, and then here's another layer, and then connecting them together. If you're not familiar with the concepts of AI with kind of what these layers do, how they're connected, or anything like that. I don't mind that at all. Just take a look at how simple this is. This is like gluing code. This layer transitions that are kind of coming together are very simple. It's kind of set. So, how do we do this and get something out of it? Well, once we run all the data through this model, we get ta-da! We get a sorter for your drawings. And then so I just connect that up with a canvas and then run it through the model, and then it can identify what animal you've drawn with this AI sorting. So I've bought aisortinghat.com and then made it so that we can check out these different drawings. Let's go ahead and give it a try real quick. Sounds good? We'll just check out AI Sorting Hat and see if it works. Way more fun than drawing numbers, right? Let's see. So we'll start off here, loading the site, and I'm going to start off with drawing a circle, and it thinks that that's Slytherin. We'll go there we go. And now I am a bird. Oh, almost lost my bird there. There you go. And that bird is in Ravenclaw. Now I can clear the sketch and then try drawing something else. Remember, do not draw a skull. Okay, that's important. Now that's a lot of fun. So we could try drawing different things here. There's another snake for you, classic snake drawing, and then I guess I could try a lion. I'm not very good at this, by the way. That it's like that's a lion here, and it's like rawr. His little paws up there. He's got a tail. He needs to have a tail, right? Okay. Boom. I'm amazing at this. All right. So I just drew a lion. And yes, of course, that comes to Gryffindor specifically. Lots and lots of fun. Isn't this better than drawing numbers like one, two, and three, and then getting categorized by that? This AI sort of like sorting hat? I think so as well. So there we are, being able to say we understand specifically what it is that we were made here, and we're able to teach a computer with that little bit of code and all that data how to identify what's in a drawing. So I think this is pretty fun. So we've got over 80,000 graphics. The final model that's trained on this is only 400 kilobytes, and we've got all this cool stuff. But I just wanted to do one more thing before we go ahead and kind of close out here because I know it would be a lot of fun. Um, well, what can we do with all that data now? We have all this cool stuff. Can we do something a little bit more fun? And I think that we can take this a little bit further. So I don't have a lot of drawings of awesome stuff from Star Trek. I don't have a lot of drawings of Starfleet Command, Klingon Empire, and Ferengi Alliance, but I don't have to because the magic's preserved in something that was done in those convolutional layers before I got to the network. So now I can load new data, only 150 of them, and then take the old convolutional layers and hook them up to a brand new network to teach that super advanced model that saw tens of thousands of images how to see something with just a few images now. Just 50 images that I've drawn and mutated just a second here. We can actually take that and then using transfer learning, and here's the JavaScript for that. I don't have that much time, so I'm going to kind of zoom past this. If you want to see how this works, I could tell you about it much more. But now we can just adjust that super advanced network to look at brand new things. And so, what about with just 50 drawings that have been done? Can we identify the cool Star Trek logos? So, let's do that real quick. So, if I go over here and I say, how is this made? I go to boldly go here. Then I load up a brand new system, and this has been taught right now on my machine. So I'm going to say load the new images, create the new features, transfer them, and then train. And now it's training right now while we're listening, and we're done. That was super fast. So let's go ahead and let's do that. See, we're already in Starfleet. Well, let's go ahead and get Klingon-y. I'm not an artist, y'all. Anybody good at drawing these things? There you go. Now I'm Klingon. And then just for fun, can I get a Ferengi going here? The simplest one seems to be Starfleet. Okay, I'm not very good at any of these drawings. Live drawing Gant. You can see why I went into programming. The Chicago Bears go into the Ferengi. I don't have to even finish drawing the symbol. Perfect. So yeah, I'm able to actually have this really cool stuff immediately with only 50 images of each, which is really cool. So I hope that you're enjoying all that and that you get to try all these out. I know I'm kind of going over in time, so we'll just kind of go into a quick review. One, yeah, we're using the magic of TensorFlow.js. We loaded and created the ridiculous data set, worked with the sorting hat with AI, and then transferred that information over to go ahead with only a mere 50 images because we were able to use the convolutional layers of the previous one to make a new one. I have a newsletter, aifyi.com, where we've got tons of cool stuff like this. I send out all kinds of neat things all the time. And if you are down to build cool stuff like this and you want to make, an alarm that goes off from your webcam, or if you want to draw something else, or if you want to use StyleGAN or cool projects like that, and you're wanting to learn how to do all this in JavaScript, I have a course at academy.infinite.red. And super cool. This is the first time I get to announce it. I also have a book coming out from O'Reilly, the TensorFlow.js book. Definitely pick that up and check it out. So follow me. My name's Gant Laborde. I post all kinds of cool science experiments, making crazy cool things in JavaScript, in Python, in all kinds of different programming languages. But definitely check it out a little bit further. Follow me right now. And then also my website's gantlaborde.com. And I just need to say thank you, everybody. Thank you, Devnexus. And I'll see you next time. Cheers.